Okay, so I'm David Matlack from Google.
And I'm Jim Mattson, also from Google.
So rather recently, we've been working on allowing a virtual machine that's using the nested VMX support to be live migrated. So there's kind of two components of this work. One half of it that I've been doing, which is allowing a VM that's using nested VMX to live migrate across different versions of KVM, where version A of KVM supports some set of the nested VMX features, and version B supports some different set of those features, and also across different CPU types. So some of the KVM will only virtualize certain VMX features if the host also has the support for those features. So the way you handle this is there are VMX capability MSRs that advertise what features are supported. So KVM advertises these MSRs to guests. Guests read these MSRs, and they only use the features that are supported. So we can add these MSRs to the virtual machine save state. KVM just has to be taught how to restore these MSRs. Currently, KVM advertises as many features as it can make available. The short story is, when restoring these MSRs, if they are a subset of what KVM and the CPU support, it's valid and you can do a restore. If they're not, then it's an incompatible migration. So for example, you could not start a virtual machine on a very modern CPU that supports some advanced feature and then migrate it to an older CPU that does not support that feature. But this would be handled at a higher level. Over to Jim for the...
Okay. And the other thing I'll add to what David was saying is that this means that these VMX capability MSRs, which are currently defined once in the KVM module, are going to have to be defined per vCPU, actually. So what I've been looking at is doing the migration of VMX state, essentially. And there are a bunch of ioctls now for get and set various pieces of state, the registers, the system registers, the MSRs. There's a long laundry list, Xsave, XCRs. I don't know if I can list them all. And you would think, well, we'll just add VMX state, and that'll round out the list. But there's a bit of a problem with restoring the VMX state, which is that if you're restoring, and this is going to get technically into details of nested VMs that maybe some of you are going to be bored with, but if you restore the VMX state last, then you've restored sregs like CR3, CR4, CR0 into VMCS 01. And then when you restore the VMX state at the end, you're going to actually want to make VMCS 02 live. Now, is that state that you just restored, was that the state of the nested guest, in which case it should go into VMCS 02? One way of handling this is you always restore the VMX state first. I've kind of leaned away from doing this because it seems like the existing ioctls allow you to restore the existing pieces of state in pretty much any order you like. I haven't looked into how they deal with illegal machine states that are comprised of pieces from two different sets. So like sregs sets CR0 and CR4, and then restoring MSRs restores EFR, and you might have an invalid combination of EFR and CR0 and CR4, and if you restore them in one order, it looks like they're okay, and the other order they're not. But anyway, I was thinking that maybe a better approach to all of this would be to have one blob of vCPU state that you restored instead of all these bits and pieces. And you could basically have a structure that always grows at the tail, and there's one ioctl to ask, how big is the structure that contains the vCPU state? And then whatever you get back, there's some amount at the beginning that you're going to understand, and then some amount perhaps at the end that you're not going to understand if you migrate this state to, say, an older version of KVM or something like that. Anyway, I wanted to talk to anyone who's interested in how best to design, save, and restore of the state of a VM that's using the nested enhancements, particularly VMX. I haven't really looked at the AMD side too much. And that's it.